I know you.
All right. Okay, so I think we're live now. Okay, people will start joining right now. Okay, now we have the attendees joining. Hello, guys.
Hi.
Hey.
Hello.
Say hi in the chat and let us know where you're from.
Yeah, please do that.
Welcome, welcome.
Welcome. You have the chat below there. And remember, you have the Q&A in the left section in the bar.
Hey, Monica from Arizona.
Chicago, New Delhi.
Oh. Wow. What time of day is that?
Bangalore. I don't know.
Early, right? Oh,
Hey,
Marco
from Mexico.
from Mexico.
Hey.
Rica, San Francisco, Denver. 7:30 a.m. Someone replied, Kirk.
Oh my gosh. Well, I'm an astronomer. I never knew there was a 7:30 a.m.
4 a.m. here, someone said.
Oh yeah, 4 a.m. is the end of my day.
Alejandro from Venezuela. Hey, Alejandro.
Hey, great day.
Great day for all of us. All right.
Awesome.
Okay, let's just wait for like 2 more minutes so people can keep joining. Mexico, Christopher from San Francisco. Feeling lucky for this to be a normal hour here, someone said from Mexico.
We tried. I just, with the regular 9 to 5, I can't keep a regular commitment during work hours.
All right, Seattle, Argentina. So I think we have from every. We're missing. No, we have Asia. We're missing Africa. That's it.
We have Nigeria.
Oh, Nigeria. We have Nigeria.
But we don't have Antarctica.
Oh, Antarctica, yeah.
Or Australia.
Australia. Maybe someone's from Australia, but they don't say it.
I think Australia is the only continent that is also a country that is also an island.
All right, so I think it's time to get started.
Okay.
Welcome, everyone. We're so thrilled to have you here and very excited. Right now, we're getting this webinar a happy start. We have here right now Kirk Borne, the amazing Kirk Borne. We're also honored to have him here, and we have Kristen here too, joining from the other side of the world from me. And so remember that this session will be recorded and put it on our website. It's datascience.live.com and YouTube too. So if your family wants to join right now, please remember to tell your mom. We always say this. Tell your mom.
Probably doesn't know.
Yeah. Tell your mom, hey mom, Kirk's here. So if you want to listen to him, this is the time to listen to Kirk Borne talking. All right. So hello, Kirk. We're very, very thankful for your time and you taking precious time of yours to be here with us.
I'm happy to be here. So great to meet you all and be a part of this amazing event.
Yay!
Awesome.
So, Kirk, I know you prepared some slides that you were looking forward to share with everyone, but before you do that, do you want to just give us a little bit of your background and what you've been up to and what you're passionate about?
Sure. Well, the last few years, I've been working at a management consulting firm called Booz Allen Hamilton. People ask me, what the heck is that? So I like to say it's 3 words, data to action. Okay, so my job is to help organizations. We're mostly working with U.S. federal government, but some commercial. And it's helping people understand what they got when they got the file of data. Like, what is it? What can you do with it? What algorithms exist? What types of patterns can we look for? And all that stuff. Make it actionable. So for me, it's answering the question that's in your data. So you have this data, what should you be discovering from your data? So that's what motivates me. I've been here for almost 4 years, like I said. previous 12 years, just some background here, the 12 years prior to that change, so that was 2003 to 15, I was at George Mason University, professor of astrophysics, but I never actually taught astrophysics. I taught data science. And so I am an astrophysicist, which is why that happened. For 20 years before that, which goes way back into the 1980s, I was working at NASA. And all of my years working at NASA, working on space science data systems, 10 of those years with the Hubble Space Telescope. Maybe some of you have heard of that thing.
Yeah.
So I had... yeah, thank you. So one of my roles with the Hubble telescope was the Science Data Archive project scientist.
Whoa.
So that was 10 years of my time at NASA. Another 10 years of my time was working at the National Space Science Data Center, where we basically were the digital library for all NASA space science data sets ever from all experiments that NASA ever ran on their satellites. So I would say that my entire professional life, and even since high school, I've been working with data, doing things with data, analyzing, discovering with data. So that's sort of how I got to where I am today, just working with data all the time. And I feel like I've come sort of full circle from working first started off in education, in college and graduate school, moved to a national lab at the Space Telescope Science Institute, to another national lab at NASA, but as a contract manager working for a private company. Then back to the university as professor, now back at a private company where I'm basically helping to train and mentor and instruct other people how to do all this stuff. So that's...
Whoa.
Yeah, that's so awesome. I'm like, my cheeks hurt from smiling. I don't know if normal people get so excited hearing people talk about playing with data and NASA, but I'm just like listening and I'm like, what a cool story.
Yeah.
Well, ever since I was relatively young, I accidentally discovered that I was good at mentoring people and giving tutorials to people. I was actually asked to tutor people in math in high school, even before I knew what a tutor was. But the math teacher would bring me out of the study hall and say, "Hey, our star football player needs some help with math. Can you? He won't be able to stay on the team if he doesn't pass my math class."
All right.
So, Kirk, we need you.
So I was teaching algebra and percentages to the football players, and then I discovered we had some kind of a brilliant student at our high school in chemistry. He was trying to get into some elite university, and apparently for some reason I got a 100%, which no one ever got on a national chemistry exam. And so I was then the designated tutor for this brilliant chemistry student. Go figure that out. I can't figure it out, but so I've always loved teaching and sharing the knowledge with people and seeing the smile on their faces like you have right now when people get that aha moment and they finally get it. I mean, I get pleasure and joy out of doing that. And as my kids were growing up, I sat with my daughters at the kitchen table doing math problems all the time.
Oh.
And now my grandchildren are not quite at that level they need algebra, but I was just helping one the other day count up to 20, and that was my 4-year-old.
That's hard enough.
My 4-year-old granddaughter, she did a pretty darn good job. And then I had my grandson actually recognizing numbers up to 60, being able to read them.
Yeah.
He's 6 years old. Well, he soon will be 6. Anyway, so whatever works for you. so
I have a 4-year-old too.
I find pleasure in this.
But you continue doing this now on Twitter. I think we all follow you on Twitter. And one of the most important things here is that you've been changing platforms for sharing your experience and knowledge. I mean, before you tried to do some classes, stuff like that. Now you're sharing on Twitter, on LinkedIn, and stuff like that. What do you think? What would you advise people that wants to be up to date to what's going on in the communities, like on Twitter or Facebook or LinkedIn?
Yeah, if you want me to advise people, I will just drink from my world's best advisor cup. Okay. It's actually fruit punch. It's actually safe. Non-alcoholic fruit. No, seriously, I find Twitter sort of my micro education platform that I can share knowledge. 200. Well, it used to be 140 characters, now 280 characters at a time. And so just those little sound bites of knowledge and wisdom around data is how I enjoy being on Twitter. And sometimes some people might say I overpopulate my tweets with hashtags because there are people who really do overpopulate tweets with hashtags. They hashtag every word, like literally every word, which makes no sense at all. Like it. I was like, come on. But the hashtags to me are tie back into my love of data curation, data discovery, exploration of data. It's an index. Hashtag is an index to help you search and find something. And I spent most of my adult career at NASA, designing data systems to help scientists discover and find data. And it was always about having clever indices in the same way a librarian would have clever indices. I always say I'm channeling my inner librarian. I guess if I had a second life, I would come back as a librarian because I just love, curating information and making it available to people and helping people find it. And so that's what I do on Twitter. And those hashtags are really, hopefully, they're actually the types of search keywords that I would use if I was looking for this particular piece of information. So it's all about sharing the knowledge, curating the knowledge, being able to rediscover and reuse the knowledge. So I was initially putting a lot of sort of articles and papers and conference links and stuff in a separate email folder years ago on my own computer, just to keep track of the things that were happening in the world of data. But in 2012, the world exploded in terms of data. Like there was the National Big Data Initiative in the United States, where the president of the U.S. put $600 million into a research fund for this.
Well,
it was also the same year that these guys at Harvard wrote this article, Data Scientist, Sexiest Job of the 21st Century. And it was about that time the McKinsey report came out that said there'd be this 1.5 million person shortage in the data science. So at that point, everybody was now paying attention to data. And so it was no longer possible to create my own little log and curate my own little spreadsheet of interesting stuff. And I said, well, I can't keep up with this. So I just decided I'd use Twitter as a way of just curating it and storing it. Because I can always go back to Twitter. It doesn't have to be on my computer. It can be anywhere in the world. And find some article or some interesting thing posted there. So that's how I got involved, is just wanting to share that knowledge and to make sure it's easily accessible even to myself. I can't tell you how many times I go back and look for my own tweets. That's fine.
Things just because I'm like, I'm going to want to see this later, and I don't care if anybody else retweets it or likes it. I'm retweeting this for me.
Well, well, what's funny about that is I sort of did that a few nights ago. There was this total eclipse of the moon, the super blood wolf moon you may have heard about.
Yeah.
And,
I saw it.
And so I tweeted something about it along with the chart that shows the time of the night and day when things were happening and the track across the earth. And, so that was useful for people to see, but also I used it to share with my own family because basically I sent a text message to my daughter's wife and everybody. I said, at like 12 o'clock midnight Washington time, and I said, hey, go outside now and look at the moon. So about 2 o'clock the next afternoon, my daughter texted me and said, oh, it's a little late now, right? But anyway, so I tweeted this thing out, and it actually became the most viral tweet I ever tweeted. I think within a day I had 1.4 million engagements.
What?
For real? Whoa, that was weird.
Or impressions, I should say, impressions. It was several 100,000 engagements, but 1.4 million impressions. And I said, oh my gosh.
That's nuts.
Yeah, exactly. It's sort of like something that was sort of there accidentally, in the sense that it was just something I found cool and interesting that I wanted to share with friends and family. And then all of a sudden, boom.
Yeah, and I think that's an interesting point, because sometimes you want something you're creating to be viral and it doesn't, and then you post the most like weird thing, and it goes viral, and you're like, what do you want from me? That has happened to me. Like, I write an article, and hey, this is my article, please read it, in like 4 likes. And sometimes I just say one word and like 1,000 likes. Like, what's happening? Why aren't you reading the things I want you to read?
Well, I think we do have lessons from Justin Bieber, right? I mean, he tells people what he had for breakfast, and he gets 500 trillion likes or something.
Yeah.
I think I'm going
He
to.
knows.
Anyway, if I ever retire, which my wife says I never will, but if I ever do, maybe I'll start tweeting what I'm wearing and what food I'm eating.
Yeah, I'm just walking here.
Yeah, something like that.
Yeah.
All right.
All right.
So
Wow.
one thing for people to remember: the name of the webinar is the Aptitudes and Attitudes of a Successful Data Scientist. So I think a lot of people are very like they're waiting for you to talk about that, because I'm also waiting for that.
Oh, that's why we're here.
Yes. So when you want, you can get started.
Okay, well, I will attempt to share my screen.
All right.
And you see it, I presume.
Yeah. Beautiful.
All right.
Yeah, we're seeing. Hey,
All right.
people, can you see Kirk's screen? Can you please confirm?
You're going to see a few confirmations. There's at least a few. All right.
Yeah,
Yep.
they can see it.
All right.
Yeah.
Excellent. Thank you. Well, just to say one thing about it. First of all, this is not intended to be any kind of formal presentation. Believe me, it's just more talking points and just conversation starters. So the last half of the slide deck will actually be a sort of a rapid fire through what I would call the 7 C's of data science maturity, which are actually 12 C's. But people may have heard of the metaphor before, sailing the 7 C's. Maybe.
Ooh, yep.
So sailing the 7 C's is just sort of a metaphorical statement, meaning just basically exploring your world, right? It's just like sort of this sort of romantic way of thinking of just going out there and exploring your world, sailing the 7 C's, right?
Sailing the 7 C's through the 12 C's.
Yeah. So in fact, So I actually started thinking of the letter C: curious, creative, computational, these kind of things. And then I said, hey, gee, there's like 7 C's here. So sailing the 7 C's, right? And then after a while, it got to be 10, and then it got to be 12. And I said, okay, well, the metaphor is only 7, but it still worked. Anyway, so that's the second half of the slide deck here. And again, it doesn't need to be like elaborate conversation on each slide, but we want to have conversation that's live and spontaneous, as opposed to dictated by the slide deck. So anyway, let me just sort of go through some things here. Hopefully it'll trigger some thoughts and questions. Like I said, conversation starters. And I'm going to have a clock in front of me so I know that I'm not talking too long. So, all right. That's my habit. I used to teach classes I used to choose the evening classes at the university, but that means that they were 7 o'clock to 10 o'clock, one time per week. So I always told my students that once I stood up to talk, I would continue talking for 3 hours. Mm. So I said, if you need to get up and do anything, that's fine. Just. But
I won't stop.
Yeah, I always told them, you're going to get your money's worth, right? You sign up for a 3-hour class, you're going to get 3 hours. And the other thing I promised them, I said, when we get finished at 10 o'clock and you leave the classroom, you'll see that all the other classes have already been dismissed and everyone's gone home already. Well, those professors are shortchanging their students, and I'll never do that. I will keep you here till 10 o'clock. So they never complained. They actually stayed. So anyway, so the discussion is not about this. Okay, so by this, hopefully you're seeing this, the unicorn here, the data science unicorn, which I think we've finally grown out of that discussion, which we had for several years, where trying to find the person. That's shown in this little graphic on the right here. The person who has all these different skills, right? But there is no single person. We all know now that it's really a team of people who bring that collection of skills more to make it successful. So if you want to know about that, which is not what this talk is about, but if you want to know about that, There's actually a report there, which is referenced down at the bottom left of the screen. Figure 8 is a company that's does really interesting stuff. Basically, they're very involved with sort of tagging and annotating data, which goes back to our discussion about curating data, that if you put interesting tags and indices on data, annotation on data, it helps people to not only find it, but once it becomes labeled, then you can apply supervised learning to it. So that's what they do. But in the meantime,
Figure 8 conference swag on me.
Yeah. Oh, I got one of those.
I think
I got one of those.
I was standing next to you at ODSC East, and I was
That's
like,
where we got it. Oh yes, I brought that little vacuum cleaner home.
Yeah, and on the other side it says clean your data.
Yeah, it wasn't exactly a wedding anniversary gift to my wife, but I did give mine to her. So, anyway, but yeah, so there's this data scientist report where they talk about the skills set of data scientists. And anyway, so that's not what this talk is about, but you can go read about that. So let's move on. So what this discussion is more about this. You probably recognize this character. Mm-hmm. And I don't know if I believe his sentence here, the first part, but I certainly believe his second part, which is he said, I have no special talent. I'm only a passionately curious person. I'm only passionately curious. And that's what we're talking about today. More really, it's our aptitudes. But, what makes us successful is that we just don't do things because we have, a skill to do it, but because we're really motivated and passionate about it. I think that's what is a signature quality of data scientists. If you think of data hackathons and data science for social good events and things like that, we have a community that's really willing to give. The weekend's nice. Just put a pizza in a room and people will come. And that's what I love about the community, is just the sort of the passion people have for doing this, and that's really what I look for in a person. I mean, I'm not saying that there are people who aren't like this, but there is a tendency in a field like ours, which has very, very high demand in terms of job opportunity and not enough people, that there are sometimes people who will go out there to try to get a data scientist job because it pays well and it looks like a great job, but they may not have these aptitudes. Okay, so that's
Kirk, do you think that somebody could be successful as a data scientist if they weren't passionate about data?
Yes, yes, absolutely. In the same way that someone can be a successful data scientist if they're a really great programmer. But over time, it's going to take more than that to sustain it. Okay? So
absolutely.
So, for example, I started learning programming way long time ago. Let's just say 47 years ago to pick a number. When I was in high school, Fortran programming, right? Well, no data science.
Fortran was my first too.
Anyways, it's perfect for scientific and engineering applications. You don't see it very much in data science. So if I had stayed stuck in the Fortran world, like some of my colleagues in that profession of astronomy, I would have basically stayed put in astronomy. I wouldn't have ventured out to where I am today. So the career path is long, and a lot of different things come to you over the course of a career. And so you need to have sort of the aptitudes that will carry you through that career. And so curiosity is one of those. That is, you're willing to go explore and try to find something out. Another one of those, which again you'll see them all at the end, is computational. That is, it doesn't matter what language it is. It's just that you really are passionate about using computer modeling and figuring out a solution through a computational technique. And that again helps carry you into the future. Anyway, so it's more about these aptitudes, which is our friend Einstein is telling us. Let's see what else we got here. So data literacy. So there's two parts basically to this sort of the theme today is data literacy and data storytelling. And sort of data literacy, we found a good definition for this. So data literacy includes the ability to read, work with, analyze, and argue with data. And I gave this definition at a conference recently, and someone said to me, gee, why are you arguing with people? And I sort of paused for a minute. I said, who am I arguing with? And he said, well, you said you want us to argue. I said, oh, I see what you mean. So I said, no, that's not what I mean. I mean, it's like, if you think of arguing, like, for example, a logical argument or an argument in a court of law where you have to give evidence and fact to support a conclusion or to support a decision. And that's what I mean by argue with data, be able to use evidence and data to propose an argument, propose a hypothesis, to support an argument or hypothesis. So working, so it's ability to read the data, work with it, analyze it, and to carry an argument with data.
Do you think this arguing part also means leaving your perceptions and judgment aside when you're thinking on data?
Well, I think you're asking about that sort of you're approaching an ethical question here or something different?
No, just trying to say that when you have the ability to argue with the data you have, so you're open to discussion, so you're open.
Oh, yes.
Have an open mind. You need to have an open mind.
That's true. That's true. I mean, argue with data can also be biased and closed-minded, no question about it, which is why I was posed the question to you like that. It can be used in a way to support basically confirmation bias, right? I have the data that confirms my conclusion, but it could be insufficient.
And there's always going to be a little bit of bias in everyone's data. And so it's, coming together and saying, okay, my caveats are this, and I believe my caveats are less than your caveats.
Well, it really comes back to the scientific approach, which you try to state your assumptions up front.
Yeah.
Right? And I used to build models of colliding galaxies, and we'd always start our research papers with, here are all the assumptions I make, okay, which are a lot of assumptions. For example, the computer model of my galaxy in no way has all the physics that a real galaxy in the universe has. And here are all the ways that it does not have. But once you've stated your assumptions and people said, okay, now within that context, I understand what you're doing here. Right?
Yep.
Whereas if you try to give the impression that, hey, I've included all possible interpretations and physics and everything else in my model, and someone could say, no, you haven't. And then it's an endless argument at that point. So anyway, so you're right. It's stating your assumptions, trying to be aware of your own biases and expressing those. And I think if we're fair to ourselves and to others, we would not only admit them, but also, be forgiving of others who have them when they do admit that they have. Because, sometimes that'll happen. And so for example, if you're doing a study of, let's just say, smoking habits or alcohol habits of college students, and I knew people at the university in the statistics department, their entire professional career were doing statistical studies of that sort. And so there were biases because there were selection effects in terms of how they selected the samples, who volunteered for the study, and so forth and so on. So you have to express
because it's never going to be truly randomized. At the end of the day, you can't assign people to a smoking cohort. And, I never deliver anything without putting the assumptions, because there's always assumptions.
Exactly. I think we're sort of describing what the data literate person should be able to do here. And that's really, part of that data science maturity, being able to do this. Anyway. Sound good?
Yep.
Yeah.
Right.
Awesome.
All right. So data literacy is sort of similar to, but not exactly the same as statistical literacy. So statistical literacy includes more of the statistical stuff. All right. Data literacy includes sort of concepts around data, like different data types, different kinds of things you can do with data, whether it's structured data or unstructured data, whether it's numerical data, tabular, video, audio, documents. So understanding different things one can do with data, how to transform it if it's unstructured into a structured form or vice versa. Anyway, but statistical literacy is something that includes understanding of sampling and means, and that the mean of a sample is not necessarily the mean of the whole population and other kinds of things. So I used to give a few little quizzes to my students when I actually taught a course on data ethics. I started the semester every time with a little quiz. And so I told them a true story, then I just asked them to break down into discussion groups to discuss it without telling them how to discuss it. I left that. So the story is I actually truly heard this sentence on a radio broadcast long time ago, quite a long time ago, way over 20 years ago, in case anyone is wondering. But a statement made by a famous politician who said that he was shocked, absolutely shocked, that 50% of the students in this country score below average on their standardized.
I saw Kate post that the other day on a couple months ago on LinkedIn. That's pretty good.
Anyway, so I'm glad you're laughing because I understand now that you understand why that's funny. But I make no comment on it. I ask my students to discuss that sentence. And it's really, really interesting to watch what happens in those. They break into small groups, and there's usually a group that gets it, that understands that, yes, in a standardized test with a huge population, you ought to have.
You can assume normality, then your mean is your median, and yep.
Well, if the standardized test has any meaning as a standardized test, then half the students will be below average.
Mm-hmm.
Anyway, but then you get other groups of students who don't have the statistical thinking going on, and they say, oh, those politicians, they don't understand anything. They don't realize how hard school is. They went to school so long ago, all those old people, they come back to school and see how hard it is. They'll go on to these big political diatribes that I would have to do a timeout on them. Timeout. This is not a politics class. This is a statistics class. Anyway, so
it does creep in though, like when for some reason I was actually thinking about this morning, and just how imperative it is that we teach people statistical reasoning and thinking, because when I was in high school, it wasn't required. I actually didn't take it in high school. I went on to get a master's degree in statistics, but it's a lot of people don't learn about confidence intervals and sampling, and then you see things like debates on Facebook about whether or not climate change is real, and it's like there's a very clear upward trend in temperature data over the years, and just because it's cold tomorrow does not mean that climate change isn't real. And you.
Right.
But so I mean, there's still people that think that the Earth is flat.
And then also too, these polls that we hear, and like we have the media telling people these things of these polls, but not telling us what the confidence intervals are or what biases are potentially in the study. And you just get this like, well, we sampled, some N, and 60% of people felt this way, and it's like, but who were those people? And right. But there's this whole population in the United States that is seeing this information and doesn't have the statistical background to say like, oh, I should be questioning how they got that population and what the methods were and maybe what the order of the questions were and like all these different things.
Yeah, that's pretty intense.
Sorry, I didn't mean to take us there, but
no, that's good.
Having this thought this morning, so it's super relevant.
Well, like I said, I would say statistical literacy and data literacy are different, but the data scientist needs to have statistical literacy as well, just for exactly the reasons you're saying, to be able to explain sample sizes and sample. I used to have all kinds of little cartoons in my class, things like, 4 out of 5 dentists chose this toothpaste. Well, maybe they only asked 5 dentists.
Yeah.
Oh, but the other one I like to ask my students was that more of a hypothetical as opposed to my politician story, which was true. A hypothetical. Suppose there's a survey that finds 10% of the population like a particular product X. Okay, 10% like product X. And after a nationwide marketing campaign, a new survey is conducted and finds that there are 90% more people who like product X. Therefore, what do you think is the current rate of people who like product X?
19%.
So you get into yes and no. You get into the discussion about this, and those who aren't thinking clearly at all, and maybe this is what the media report. So I say maybe the advertising commercial, if this was a true, not a hypothetical story, maybe they're tricking people into just adding 10 plus 90 and saying, oh, gee, 100% people now love this stuff. Okay, so maybe they're sort of like playing off of people's lack of statistical or numerical literacy.
Yeah, same thing with sales at the mall when they say like you get 50% off, and if and like this other side is an additional 50% off, and it's like, well, that's not 100% off. It's, once you take the first 50 off and then the second 50, you're still paying for 25%, but people don't, not everyone gets that.
Well, let me address your answer to the question, which is 19%, right? So maybe the answer is 19% because maybe what they meant was 90% more as a rate. So 10% of the population liked product X, and now 90% more of that, so it's a 19% rate. But what if you take the statement literally, 90% more people like this product? All right. So maybe the first survey they did, all right, they asked, let's say they asked 100 people, and 10% of the people like the product. That's 10 people. Then they do the second survey, and they ask 1 million people, but only 19 people now like the product. So 90% more people like the product.
Oh, my mind wouldn't even go there.
Exactly, but there's an entire book on how to lie with statistics, and believe me, this actually happens. You change the sample size, and then you say you don't use a rate in the next sentence. You use an absolute number, 90% more people, and you've just lied with statistics, or I should say, I just lied.
Kirk is a liar.
Kirk is the liar, exactly. Liar, liar, pants on fire. Oh, whoa. Anyway, so, okay, let's move along a little bit here. This is fun. We'll be here another 6 hours at this rate. I hope you brought snacks.
People are getting their money's worth, even though it's free.
Yes. I hope you brought, of course. I forgot to tell people, if you get hungry during all this, I think Kristen or Favio will fax you some food.
Yeah, because I just have a fax machine. Everyone has a fax machine.
Oh boy, someone says popcorn memes are incoming. Oh, I want pizza memes. Sorry. Anyway, let's move on here. So, okay, just a few quotes. If you I don't want to read all this, but I will. If you torture your data long enough, it will confess to anything. That's sort of funny, but it's also extremely valid in the world of big data because I've just been having discussions just in the last 2 days on two different occasions where this came up, where if you have a large enough data collection, you'll find almost any kind of pattern or trend in there, right? So for example, a Six Sigma event. Okay, Six Sigma is very, very extremely rare in statistics, right? It's 1 in a million, which is why in a lot of total quality improvement programs in business, they used to use the Six Sigma program decades ago. I remember that. So Six Sigma basically came from the world of manufacturing, where basically you had one defect out of a million products that came off the assembly line. Well, now in the world of big data, if you have a trillion data points and something is 1 in a million, that means you have 1 million examples of it, right? So you have 1 million examples of this thing. Wow, look, this must be significant. No, it's just a Six Sigma event. So you'll find correlations and patterns and trends all over the place in large data sets, and we have to be aware of this when we are analyzing our data. So,
Same thing if you let your hypothesis test run long enough, and it's like e-commerce, and you're getting hundreds of thousands of visits to the site a day, and your result isn't statistically significant, and you say, I'm just going to let this run 3 more weeks. Like, if you just let it run forever, any difference will eventually become significant.
Well, I have a blog.
One of the ones that I have to always, like, coach people through. We can't just decide after we've, designed this test that we're just going to let it run until you get the answer you want.
I'm going to move that screen over here. Hopefully I didn't destroy everything you're looking at. I wrote this blog a number of years ago about don't be fooled by randomness.
Mm.
I don't know if I can find it now, but anyway, so I actually did all these Monte Carlo simulations of simulated coin toss. And the idea was if I did enough coin tosses just randomly, like I actually did tens of thousands, I simulated, I was actually able to find sequences of maybe 12 coin tosses in a row, which were all heads or all tails. Okay. And
yeah.
Just at random. Okay.
That's why when I'm at the casino and people are like, when it's been on black for 5 times in a row or whatever, and people are like, oh, I'm gonna go to red now, and it's like, I don't know, be black again. Still 50.
Yeah. I think I found the article. I just put the link to the article on the chat.
Yeah, it's called 7 Traps to Avoid Being Fooled by Random.
Yeah, that one. Yeah.
Yep. And I'm trying to type and talk at the same time. That's always a bad thing. I am going to cut and paste a very short version of the same link in case someone was somehow stuck in typing land as opposed to clicking land. Same thing. All right, let's see where I am here. Can I find myself?
There you are.
All right. Meeting control. I want to bring up my meeting control. They all sort of disappeared. Anyway. So 42.7% of all statistics are made up on the spot. Okay, this was one of the jokes I used in my stand-up comedy routine in New York City last spring. I think Kristen was asking about that. Actually really happened. An item on my bucket list. I always wanted to do stand-up, and I actually had an opportunity at a beautiful nightclub in downtown Lower Manhattan last spring, and I did it.
Oh, that's awesome. Did people laugh at your jokes?
They did. As my wife and daughter crawled under the table saying, "No, you're not going to do that." But I did it, and people did laugh.
Do you have that on tape?
Yeah, where can we access that?
Yes. Well, there's a long backstory which had to do with why I was doing this, and my son-in-law was doing a pitch at a Shark Tank event, or equivalent to a Shark Tank event. He was doing a pitch for his startup, and there were like 14 other startups pitching that night, and so each founder of a startup could have a person introduce them. So I introduced my son-in-law, and since I had the stage, I said, well, as long as I have the stage. Here you go.
Here you go.
and so I actually can share the link, but I don't want to get too disruptive of what I'm doing right now, so I'm not going to do it at this moment. But anyway, like I said, it's there. I'll share it with you later, and if I have the nerve, I'll share it on Twitter. But anyway. So Stephen Wright jokes were what I told. So anyone who knows Stephen Wright knows what I'm talking about. He's extremely dry humorist, where he says things like very monotone. 42.7% of all statistics are made up on the spot. He also said, I went to the store to buy some batteries, but they weren't included. You can't have everything. Where would you put it? It was really that bad. Yeah, sorry. I spilt some spot remover on my dog. Now he's gone.
Oh, the dog's name is Spot.
Yes. Oh, okay. Let's move beyond.
Okay, yeah.
Let's move beyond that. Because it's important to state that it's now beyond any doubt that cigarettes are the biggest cause of statistics. Okay. So data literacy comes in two parts. Let's get back to, to the theme tonight. And
Yeah.
how to use data correctly and how to use data ethically. You know, entire articles, art and presentations, and entire lectures, and in fact, entire courses that I've taught on this topic, including a link there on the screen to my data ethics course from way back when. So Dilbert is good for finding examples of these counter examples of these practices. For example, how to use data correctly. So if you're familiar with Dilbert, you know that the message goes, the pointy hair boss is the sort of the clueless boss, and Dilbert is the the geek who knows a little bit too much technical stuff. And so the boss comes in and says, hey, we can use this particular database to size the market. And Dilbert says, hey, that data is wrong. And the boss says, well, hey, we can use this other database. And Dilbert says, well, that's also wrong. And then the boss says, hey, well, can you average them? And Dilbert says, sure, I can multiply them too.
I saw another Dilbert one where he was like, that data's bad. And the response was, well, does it say what we want? And he says, yes. And the guy goes, well, then the data's good. It's not bad.
Well, that's sort of like the last one down there where the boss says, we have this database full of customer behavior information. And then Dilbert gets all technical where he says, hey, yeah, we can use nonlinear math and data mining technology to optimize our retail channels. And the boss goes, well, that's the same thing as spam. We're having a good conversation here. Anyway, so it's really those two dimensions: knowing your data, what you can do with it, do it correctly, and then how to do it ethically. And I actually, again, I like taking things like this cartoon, especially the first one there, and then spinning off a more serious dimension of it, which is if you know about the reduction to the mean in mathematics and statistics, where if you measure something multiple times, you do multiple samples of a population, and you take the mean of all those different subsamples, and eventually you'll get a better estimate of the mean of the population, the regression to the mean. So averaging is not a bad thing to do with different data sets, right? So the boss was not totally off the mark when he was suggesting that you can average the data to calculate it. But what about this Dilbert comment, multiply them too? Well, I realized that Dilbert was not talking about the arithmetic mean. He was talking about the geometric mean. Now we're getting interesting. So geometric mean is really interesting when you have very large dynamic range in your numbers. Okay, so in astronomy we call that logarithms. Okay, so we take logarithms of number and then take the average of the logarithms, and that gives you more of an estimate of sort of the geometric, mean of it is the geometric mean of the value, because the average. For example, I used to tell my students another true story. I said I went to lunch once at this astronomy conference, and there were 3 of us at the lunch table. True story. There were 3 of us that were having lunch together, and the average net worth of the 3 of us was over $1 billion.
Were you with a billionaire?
So I asked my students to comment on that statement, and of course some of them would say, wow, you professors must make a lot of money. and after I got through laughing for 35 minutes, I explained to them that wasn't true. But it turned out one of the people at the lunch table was the former chief architect of Google, who had made his fortune, who was a lifelong amateur astronomer. And so he retired from Google with his billions, and he actually created his own amateur observatory, where he created 72 telescopes around the world, robotically operated, so that teachers and students in classrooms worldwide can study the sky at any time, because there's always some telescope looking up at the sky. And so we were having this great conversation, and there were 2 of us sort of typical professorial types and this multi-billionaire at the table. So anyway, so the outlier, taking the average didn't make any sense. Anyway, so that's another story for another day. Let's move along a little bit. So I want to move past some slides here because of the time. And these slides will be available. I'm just going to move a little bit fast. So we're going to talk about, finish up with sort of the aptitudes and the attitude. Okay, so we'll back up a slide. So, like I said, the last half here is going to go by really fast because it's just these 12 C's of the successful data scientist. So these slides you'll find later. Curious, Okay. Asking questions, that's being passionately curious about your universe. Oops, let me do this another way. Creative, and it's really interesting. There's a lot of discussion about the connection between design thinking and data science. You'll find literature on this in a lot of different places. And I really like this because it's really about what we're delivering is our solutions to customers, to stakeholders, to other people who may not understand all the stuff that we understand. And so we need to think about what we're doing and how we're delivering it and explaining it to people. So that design thinking is important to what we do. And that's part of our creative process, not only create and design things, but in a way that, that meets a customer's need or a stakeholders. We're computational. Okay, so here's my cartoon I put together. I frequently go to universities, data science meetups and boot camps, and I always get this question, should I learn R or Python? My answer is yes.
Somebody had that question in the Q&A box.
There's actually a question in the Q&A from Eugenio asking just that question. So, Eugenio, the answer is yes.
Correct. Because it's about being computational, right? So if you asked me 40 years ago, I would say Fortran is what you need to learn. If you asked me 25 years ago, I would have said Fortran, maybe, or C, maybe. But what happened in between there 36 years ago, yeah, thereabouts, I was at the University of Michigan on a postdoctoral fellowship, and the language du jour was Pascal. It was all over campus. There were bulletin boards and announcements everywhere that the language to learn of the future is Pascal. Every other language will be obsolete. Well, I'm still waiting.
Learned Pascal.
I'm still waiting. Anyway. So languages will come and go, but if you're a computational person, if you think computationally and you're computationally oriented and you like to solve problems computationally, that's what's important. It's not the specific language.
If you get good at Googling and using Stack Overflow, and you've got one language, you can learn. So when we get to the last of my C's here in a couple seconds, I hope, I'll spoil the fun. The last of my C's, which we haven't got to yet, is continuous lifelong learner. And the point is, you're willing and able to learn new things, to learn new languages, learn new techniques, new algorithms, learn new stuff. I mean, I wasn't taught. I love this field so much is because it is changing. Like you can't avoid it.
Right.
But like that's what makes it interesting and beautiful. If it was the same, I would get incredibly bored. Like really fast.
Well, this is a fundamental characteristic of this profession now, is that what we would call the doubling time of knowledge or the turnover time of new knowledge it's basically 2 years. I mean, sort of within 2 years, what we're talking about is different. I mean, we just started talking a lot about deep learning a couple years ago, and now we're starting to talk about, other kinds of things, like capsule learning. What the heck is that? Well, I think we're going to hear more about capsule learning. Reinforcement learning has suddenly become part of the big conversation since, the AlphaGo success story. So the things we talk about and do change rapidly. So you got to be always learning mode. So computational, collaborative. See, these are one-word slides. I don't need to read all these. Collaborative, critical thinking. And you can come back and read all this later. Community focused. That's the other great thing about our community is we really want to do data science activities like hackathons for social good. And my company, we sponsor the data science.
No, sorry, go ahead.
Yeah, so my company works with Kaggle to sponsor this annual data science bowl. And the first few years we put up all the prize monies. One year we actually got a private foundation to pony up $1 million for the prize money. So you can read about us at datasciencebowl.com. Anyway, I don't want to go into that. That's a long story, but it's really great. You're a courageous problem solver. And I love this quote from our friend Kirk Borne. If you're going through hell, keep going. But when things are hard, I mean, you're solving hard problems. We don't just stop. We keep going. And that's what tenacity and courage that we have as a community of people. We're cool under pressure. I like this one. It's in the psychological world, it's called a tolerance for ambiguity. And that's a real thing. That's a real thing. And they discover that people who are successful scientists, especially in sort of the math and statistics realms, have high tolerance for ambiguity. And part of what that means is you realize there's no necessarily one right answer. There's probabilistic answers to things. Only a probability of this or that, or yes or no. And some people just can't handle that. They want the black and white. They want the yes or no. So you have to have this acceptance that your answer may only be probabilistic.
Yeah, and I think some people have trouble delivering when they know, when I deliver something, I'm going to talk about, next steps or potential improvements, but I still get that increment in, and you have to get comfortable saying, okay, this is something that can be improved upon, but I'm still going to deliver this, and we can iterate, but like there has to be a stopping point because you could go on forever sometimes.
Yeah, but that's just the way science works. I mean, and we need to think about that because no one will ever post a paper with the final answer to anything, and that's the beauty of science.
Well, E equals MC squared still sort of working.
Yeah.
No, I understand your point. I definitely understand your point. And that's science. I mean, science is a process, right? It's a refinement process. You collect new data and refine your hypothesis. And that's what we are doing. We are doing data science. Mm-hmm. I always tell people the two most important things in data science are the data and the science. Okay?
That's it.
So that's all you need to hear from me tonight. Thank you. Okay, let's get this finished, and then it's going to be at the top of the hour. But anyway, so consultative. Now, what that means being able to have the conversation, listen to, pay attention to what your stakeholder wants, and be able to deliver that. They may not want the shiny new deep learning algorithm with back propagation and hundreds of hidden layers and convolutional recurrent networks, and they'll say to you, "What the heck is all of that?" You have to be able to listen to what they want and deliver what they want, and it's all about the pull from the customer as opposed to pushing your shiny apple. And that's what one of the things I mentor a lot of our young data scientists at my company, because we're a consulting company. And a lot of our young data scientists, I mean, they're brilliant in their programming skills and machine learning skills, and I mean, they do circles around me. I mean, just unbelievably talented in those areas. But they need to realize, of course, it's not about the shiny, fancy algorithm that the customer wants necessarily. Really, I want to know the predicted outcome from this set of events. And that could be a pretty simple model that can tell you that without all the deep convolutional layers involved. Anyway, just thinking about that, being able to listen to what the customer needs. Maybe your customer is, we had a customer who was very deep in the math and he wanted the heavy mathematical solution. So that was important to listen to, that's what that customer wanted. Okay.
Yeah, of course.
Compassionate, empathy, like the quote says, your customer doesn't care how much you know until they know how much you care. I mean, that sort of goes back to the other thing, but that compassion goes back to, like that community focus and being willing to go out and solve problems, like the Data Science Bowl and other types of hackathons. Data storytelling, good communicator. I've given whole talks on this topic about telling the story associated with the analytics you've done, with the model you've built. What's the what, the so what, and the now what, and being able to give that elevator speech, that 2-minute or 3-minute explanation of what you did, now what, so what, now what type of thing. And then that last quote there, people will forget what you said and what you did, but they will never forget how you made them feel. I mean, so how are you communicating what you've done to people, that they can feel the impact, they can sense it, they can know it, and as my mother used to say, you know it and you know her. And then the last one here, continuous lifelong learner. You can read all this stuff, or you can just follow this guy on Twitter.
Awesome.
Anyway, so here are the 7 C's. Actually, there's 12.
Plus 5.
7 plus 5. Sailing the 7 seas, the individual's journey today. So I decided to play off on this metaphor of sailing the 7 seas. I love this quote. Since we are scientists exploring vast and endless seas of data, this is a real quote. I really love this. I said, poets, this poet said, if you want to build a ship, you don't drum up people to gather wood and assign them tasks, but rather you teach them, yearn for the vast and endless sea. And that's how you can get data scientists to show up on hackathons on Saturday mornings to do stuff. I mean, they just want to explore it. We want to solve hard problems. We want to explore data to find solutions. Hard problems, to find the interesting patterns in the data that can inform better decisions or outcomes. And that's what motivates us, right? And I think that's really kind of exciting to be part of this. And that's the last slide. There's a link to where you can get all the slides, especially the ones I went through very rapidly if you want to read some more. Everything on that, every graphic on the slides, hopefully every graphic on the slides, including this last one, are all clickable. So once you download the PDF, you can just click on any of those things and download those things. All those documents are free downloads that you see there. And the field guide to data science, that field guide to data science is the best book in the world for data science.
You wrote that, right?
I did not, but I did write 2 pages in it. But before
Are they
I get
the best 2 pages?
of course. No, but it's the second edition, and the first edition was written and published before I left the university, and it was one of the reasons I left the university to go to Booz Allen, because I saw the investment they were making, giving this away free, and a lot of the stuff they were doing, and I said, I want to be part of this team. I mean, these people are producing amazing stuff. They're giving it all away. I want to be part of it, and so once I got there, they told me they were working on the second edition, so I got to contribute a little bit there. But it's a pretty impressive document there. It's, like I said, it's like free download PDF, or I have hard copies, but sometimes I carry with me to conferences. The problem is it's made on very heavy stock, dense paper, so it can probably survive a nuclear holocaust or a hurricane. So I bring like 20 copies with me to a conference, and it adds like 50 pounds to my luggage. So.
Whoa!
It is impressive. So I don't
do
do
that. So for putting the slides together and sharing all these resources with people, that's awesome. That if people want to, download this and look for more, that you're just like, here it is, all organized for you. Go enjoy yourself.
Yeah,
and we will make sure to put that also on the datasciencelive.com webpage. So if you cannot type it right now, or you're watching this when it's recorded, don't worry, we'll be putting this on datasciencelive.com webpage too.
And I think, as I normally do, I'll just put this link on my Twitter feed. So,
oh yeah,
awesome.
So just put it wherever you want. Put it wherever you want. I'll put it where I want, and we'll all be happy.
Yeah, I loved some of the points that you touched on when I think about like collaborative and courageous and consultative, and they all sort of in communication, like a lot of those are they work together, because like a lot of the words are motivational and you see the positive, but when I think about my role, there are definitely times where you can consult up front to make sure that what you're delivering is going to meet, and also letting your stakeholders know that you value their opinion by getting their opinions up front, and then you build this model, and in the deliverable I'll put all the features. And at this point, I just put a list, and it'll be like a couple hundred, like here's all the things I considered, the different variables while building my model. And, you explain the final model, and you talk to them, and they'll still say, did you consider this? And it's like, yes, of course, that's in my list of 300 variables. But like there is this, amount of like business acumen you have to have, because there are going to be times where you're trying to explain a test design that isn't necessarily what they want to do, but they don't understand that the testing it their way isn't going to allow them to measure the success criteria that they're hoping to measure. Or the example that I just gave with my model, and like you do have to take a deep breath and keep your composure. And honestly, like, it's taken some practice over my career to get to that point where, like, you know, I set myself up by making sure that, like, I'm hand holding and I'm communicating effectively, but there's still going to be those questions that, you know, and the follow-up work that sometimes seems a little redundant, but at the end of the day, you are, you know, a supporter of your stakeholder or your client.
Right. I think I even go so far as to use language I learned at NASA, which is sort of the system engineering approach, where you first elicit requirements from an end user, like what is it you want this thing to do? Mm-hmm. Like when you build a system, it's no different than when you build a model. What is it that you want the thing to do? So you have user requirements. Are you optimizing something, predicting something, detecting something, whatever? Then from the user requirements, you know, you derive from that, you know, sort of what are the functional requirements? Like what does the thing functionally have to do for a person? Like, does it need an interface? Does it need an input box or an output graph? You know, sort of what are the functional requirements to answer those very human requirements that the person is talking to you about? And then from those functional requirements, you go all the way back to system level requirements. So okay, if I build this thing, you know, what are the components that go into the complete system so that it delivers the functions to satisfy the user's wants and needs? And so you go, and that's just an oversimplification of system engineering, but that's basically what you're doing. And it starts at that first conversation of figuring out what does the user want from this thing, mm-hmm. instead of assuming that, oh, you must want this and you must want that. Well, maybe they don't. You know?
Yeah, just sort of.
Now, there's a question in the panel box if I could have a second to answer it.
Of course. Yeah, no, I'd love for you to answer the questions.
Why is it a science? And again, this is something I normally elaborate more on when I have time, but it's a science because of the science is a process that begins with observation. And that's what we're doing. We see something either through our sensor data, our measurements, our data, or just through our intuition. We see something, expect something, and we have a hypothesis. We infer a hypothesis from our observations of the world that I think this is how this works. For example, I think if I put on this recommender engine for these products, I'd get customers to buy more products. Okay, for sort of traditional A/B testing in the statistical world, right? So you have a hypothesis that you infer from the data, then you design experiments to test your hypothesis to see if it works. And from those experiments, you collect new data to validate or essentially measure the performance of your hypothesis, of how close it is to reality. And then since it probably didn't get it right the first time, you refine your hypothesis, then you go back. Okay, it's a cycle. So science is a cycle. Data science should be a similar cycle. You refine the hypothesis, you refine the model, and you design an experiment to test that version of them. Now, I actually wrote a whole article on this recently called the cold start problem. So if you're looking for, for links to share on the box here, the cold start problem in data science. And the point is that we have this sort of back propagation or feedback loop in almost all of our data science activities, where we build a model, we measure the error rate, and we do some kind of gradient descent to diminish the error rate, whether it's back propagation in a neural network or least squares if you're doing regression or something of this effect. If you've ever done a k-means clustering algorithm by hand, you know exactly what I'm talking is you're constantly recomputing the means and going back to the beginning and recomputing the means and going back to the beginning and recomputing the means.
You said k-means and I started nodding my head, and then you said by hand and I was like, nope.
Correct. You're right. But when I did this in my undergraduate class, I did do it by hand just to show them the process.
Yeah.
Where you assume completely random initial means, and you can iterate till you get actually good answers. And that's what happens with the weights in neural networks, right? That's why back propagation actually works. Is usually the weights and the edges between all those hidden layers are assigned randomly. like the number 1, they all have weight equal to 1, then you run a model. I always tell people, okay, so this was one lesson I forgot to put on my slides. I'm very sorry. The most important lesson in data science is you have to make 2 mistakes first in life. So your most successful data scientist needs to make 2 mistakes, because the way you know whether to improve, how to improve, I should say. Once you have 2 points, two error measurements on a model, you know whether to keep going in the same direction or to reverse and go in the opposite. So you learned in algebra in 5th grade, you can't get a slope for a line without 2 data points. You can't get a slope for one data. So you need to have 2 measurements of performance to know which direction to continue iterating and adjusting the model. And so that's what gradient descent is. That's what backpropagation is. That's what k-means does. That's what linear regression does. That's what everything we ought to do. It's that scientific process, the scientific cycle of measuring and evaluating the performance of our hypothesis and refining it, then measuring the performance on the next one and say, did my adjustments make it worse or better? If it made it better, I keep adjusting in that direction until it reaches a minimum error or maximum performance, whichever, however you define performance, either minimize it, error, or maximize accuracy, whatever. Is if it's getting better, you keep going in that direction until it reverses, and vice versa. If you made adjustments that made it worse, then you turn around and go the other way. And so the joy of deep learning and TensorFlow is that gradient is not performed on a 2-dimensional XYZ plot. It's performed in a super high-dimensional parameter space, where those tensors are essentially the slope, that is the gradients, in high-dimensional space. And so all the adjustments to the weights across all those millions of edges in that deep network, the adjustments to the weights are calculated automatically on the tensor board for you, and you propagate the errors to the weights that have the most to least significance in terms of producing the output. Okay, so you appropriate the error in proportion to how much of that edge contributes to the error. And you don't know that until you build at least 2 wrong models. So the most successful data scientists, when I interview a data scientist, I want them to come to me and not say, here's all my success stories. I'd rather them come to me with a portfolio full of failed stories. Tell me how you improved on those failures. Tell me what you learned and what you did. So I say, tell me about the gradient descent of your professional career.
That's a great question.
Where did it not turn out the way you wanted, and what adjustments did you make to get it back on course? I want to hear those stories, because that tells me more about your maturity, what you've learned, and what will you do when you encounter that again in life, because you will encounter this again in life, because I encountered it plenty of times in my lifetime. I mean, I could share stories, which I will not share online in a live webcast, about some pretty crazy things that I experienced as a scientist from other scientists. But we'll just stop right there.
And the answers normally come at like 2 a.m.
Yeah.
Like you wake up and you're like, ooh, the way I've been approaching this, I completely bungled that up.
Yeah. Well, there's a fantastic quote which applies to 3 things. It applies to machine learning algorithms, it applies to normal life, and it applies to teenagers. Assuming that teenagers are not normal life. But anyway, and that quote is that good judgment comes from experience, and experience comes from bad judgment.
Oh, then I have a lot of experience.
So when we build when we build machine learning models, we measure an accuracy. The very first model, like that neural net, we assume all the weights are equal to 1. Bad choice. You build a k-means clustering, you just assume totally random initial mean values. Bad choice, right? There's all kinds of things that we intentionally make bad choices. Do it again.
Start somewhere. Yeah.
Right. Start somewhere. That's the cold start problem. You start somewhere, then you adjust the parameters and build a second model. And did it get better or did it get worse? From that experience, you learn how to have better judgment in the next model.
Yeah, and you hope you can converge.
And that ties right into The first definition of machine learning I ever read, actually over 20 years ago, when I first discovered the field of machine learning, because this was not taught when I was in astrophysics school. The first definition I ever saw is machine learning are algorithms that learn from experience. And I looked at that and I said, what? It's got to be more complicated than that. Machine learning is the set of mathematical algorithms that learn from experience. And it took me the longest time to really parse those 5 words or 4 words or whatever. And I finally get it. I mean, the experience is the gradient descent, right? You measure something, it gets worse, it gets better, and you adjust accordingly. And machine learning is that iterative process, which is why it is a science. It's an iterative cycle of improvement, improving your hypothesis.
And that's why we should be able to explain to our customers and our stakeholders in clear language that they can understand, because at the end of the day, even if I'm building a neural net, it's learning from past data that I've given to it, and under, these scenarios, we can expect it to look this way, and under these scenarios, we can expect it to look this way, and there absolutely is language that we can use to build trust and make it so that we're not like throwing a black box at people.
Yep. Well, first of all, thank you, Favio, for sharing that link to the cold start problem. But yeah, I agree with you, and that's part of that what we call that cool under pressure tolerance for ambiguity, right? And that is, you may have clients who don't appreciate the fact that your first model is not the perfect model. Well, let's say it another. Let's say it another way. You know that your model is not the perfect model, and you communicate that to them, and then they want to dismiss you. Because they say, "Well, I don't want people to build me imperfect models." And then you have to explain to them, well, that's how the process works. You iterate. And I actually had a conversation with the client. I talked about the fail fast, learn fast mentality, which is the data ops or the DevOps approach to data science. And he said, we don't fail here. And I said, well, I had to back up and say, well, I'm not talking about strategic failure. And it turns out, since I was talking to a client who understood military terminology, and I'll just leave it at that, I said it's about, like, sometimes you have to lose the hill to win the battle, and sometimes you have to lose the battle to win the war. It's about tactical failure. That is failing at the right place at the right time in order to win the overall war, so to speak. Okay, so you build
failing fast.
Yeah, fail fast, learn fast. Mm-hmm. Because there's too many cases of people who have built the big battleship or they built the big airplane in 20 years in the manufacturing shop, and if they take it out for the test run and it doesn't work. There's a thing called the Hubble telescope that had that problem with its mirror. Some of you may have lived through that moment.
I remember that when they put it there, so it was a problem, right?
Yeah, there was a big mirror problem, and we were called the Techno Turkey, and it was an embarrassing time to be an astronomer because all the late night talk show hosts, they weren't really ridiculing political figures, they were ridiculing astronomers, and that was kind of hard to, because people built this thing and said, oh, it'll work when we launch it. No. Anyway, that's another story. But we ultimately solved that. We ultimately solved that problem using data. That's actually a pretty profound story in the Hubble telescope legacy, how they collected data to figure out how to fix the problem while the telescope was still in space without bringing it back. And that was absolutely a phenomenal accomplishment based on data entirely.
That's incredible.
I think we have time for one more question. There's there are 10 questions now on the Q&A. So wow. I'm just going to randomly pick one now. I'm not saying. So, okay, we have this question now. Where do you think this field is going in the next 5 to 10 years?
That's a multifaceted question. Because I think what's happening with data science is it's starting to be basically sort of blended into every discipline. It's becoming sort of a tool in the same way like the internet. We don't even think about internet as a tool, right? We all use it every single minute of every day, whether it's your smartphone or whatever. So we don't have that conversation. Where's the internet going? So, but 20 something years ago, we were having that conversation about whether you would ever do shopping on the internet. And that was like a big question. Would people ever shop? I remember a conversation when I was at NASA when all we had were flip phones. And I told people we really need to design our web pages so that people can view them on a small screen like a mobile phone. And people looked at me like I was crazy. He said, why would anyone ever want to look at a web page on a telephone? So what happens is that the technology that is sort of standalone or maybe stands on its own feet by itself now will become blended and in a sense almost invisible to the touch because it's blended in. And I was just reading an article about the data science and AI sort of penetrating in the healthcare field, specifically in sort of clinical analytics, clinical tests, radiological scans and diagnostics, whether it's X-ray machines or other kinds of radiological imaging or whatever. The tools now are no longer the stethoscope and the X-ray film, where the guy or gal holds the film up to the light and says, "Oh, you have a tumor here, I think." But it's now algorithms, and the algorithms don't necessarily need to remove the physician from the loop, but they tell the physician, pay attention to this thing here because this is the thing, or this is the patient who needs the attention. So it makes the triage more efficient, and that's what I think data science and machine learning will do in the next few years. We'll see more and more decision making sharpened to the cases that really need our attention. And so I think what's going to happen is we're going to start automating the discovery process of here are the things that we don't need to pay attention to. Here's some things that are interesting but not as important as these other things, which are the things that really need your attention. So we're not taking the human out of the loop, but we're putting the human into a better position. I mean, people talk about future of work and how scary all this is and jobs will go away, but I think it's going to be the opposite. There will be jobs that will go away, but in the same way that every industrial revolution that has happened, right? We don't have a whole lot of blacksmiths shoeing horses these days. Okay, so things will change. But the thing is, people will be doing more knowledge work, more work that's in tune with their expertise as opposed to busy work. Instead of plowing through the 50 or 500,000 emails in my inbox, which we were talking about a little while ago.
Yeah.
I will have an algorithm, and Gmail. I actually use Google Mail, and it has something like this. Sometimes messages are popped to the top.
Yeah. It says, hey, 5 days or whatever. Yeah.
Yes, it says it's been 5 days and you haven't seen this. And I said, oh, thank you. But it's that kind of thing where it'll help us do our work even better, and actually tap into the cognitive skills and abilities that we were trained to have, as opposed to just shuffling paper around, so to speak.
Mundane, yeah.
So I think that sort of triage aspect of where we're using the data science and the machine learning to make our jobs more efficient and more effective. And I like to use those words separately, because efficiency means a given task you do more efficiently, that is more quickly with minimal, the least amount of resources. That's reasonable. That's efficiency. But effectiveness is you're actually solving and doing the things that you need to do, more of the things that you need to do. I can do a lot of unimportant things very efficiently, and unfortunately, that's how I spend most of my day. I click off all the little simple things on my to-do list, and there's all those hard ones that are there every day. It's not very helpful to just do a lot of really small things efficiently, because you got these big important things that really, it's going to help us to be efficient and effective, where we're doing the things that really need to be done. That's effectiveness. And so I think that's how it's going to help us in both those two dimensions of productivity, efficiency, and effectiveness.
I love that. I love the rosy outlook, because a lot of times you talk to people and their outlook isn't so rosy, and I am a rosy person, and I just really enjoy it.
Well, as long as
enjoyed that.
Well, Favio is an expert at putting links to my blogs here. Here's another one. I actually wrote an article a year ago called The Year of Experience, or The Age of Experience. and on the website datamakespossible.com, datamakespossible.com.
Check it out.
And the point I was making there, so experience includes customer experience, user experience, digital experience, patient experience, but also employee experience. And it's a two-part article, and the second part talks a lot more about employee experience. And that is using all this stuff to do exactly what I just said. I mean, for example, in customer call care centers, I heard someone give a talk when I was actually at a conference in India, and they're saying, there's a lot of call centers in India, and you don't find too many people coming home at the end of the day saying, hey, I love my job, because there's a lot of really difficult people who call those call centers. And some of the questions are sort of repetitive, and the answers are already on the website, and do I really feel like I'm being a good employee doing this? Whereas when you have these chatbots, the chatbots and conversational bots can help answer the more straightforward questions the customer has, or the questions that are already on the company website, the FAQs. And then the bot turns the discussion back over to the human contact center person to solve the difficult problem that the customer has, the more complicated, complex problem. And now the employee's experience is improved because, hey, what I know is important. The things that I'm doing here are important. I can solve this hard problem because I know how to solve this hard problem. As opposed to the person who's the 1,000th person of the day who calls and says, where are your FAQs on your website? Underneath the word FAQ. So I think employee experience is going to be the positive, ROI, if you will, return of investment of the data science things we're doing, and that people are going to find more joy in what they do because they're going to have this assistant, this virtual assistant, again, blended into the workflow of their day-to-day processes that are going to make their work more enjoyable, and we can be part of that conversation, part of that success story by what we're doing.
I think that's an awesome question and great answer. And I think the future is uncertain, but what you said is like, I hope that's the answer to that question, because that's a very good thing for the world. And there's a lot of misconceptions about AI and machine learning that people are very scary about what's going to happen. But I think we're going in the right direction. And if all the companies and people around the world listen to what you say and what others are saying, that there's no harm, it's only like beauty and help for people, I think we will not be worried but happy about what's going on with it in the data world.
Yep. I think the another good quote when someone asked about the future is that prediction is hard, especially about the future. So I was
forecasts are wrong like 100% of the time.
I was going to lead with that joke, but I guess it was better to be more serious.
All right, so I think now it's time to end this awesome webinar. Remember, this will be posted later on the datasciencelive.com webpage with the slides from Kirk. And we thank again, Kirk, for your time, for your precious time, for us to be here. It was an amazing discussion. We learned a lot, and we will be sure to read all the articles you put there and these books that are just. I just watched the field guide for data science, and the art in that book is stunning. It's beautiful. So
yes,
congrats for just.
And I can agree with that statement because I had absolutely nothing to do with the art.
It's beautiful. It's beautiful.
It's one of the things that I never was good at: art or dancing or singing.
All right, guys.
Well, thank you all. I put a link there to that article on the year of experience, and it talks about that employee experience part 2, I think. But thank you all, everyone, Favio, Kristen, appreciate it very much.
Yeah, thank you so much for coming, Kirk. I really appreciate it, and I really appreciate that you put all these slides together, and it was just so great to hear from you. Thank you.
You're welcome. I'd love to come back sometime without slides. So we'll have Data Science Unchained
Ooh.
You're welcome every day.
Yeah, anytime. You just let us
I'd love to have just a Q&A with your audience. I mean,
Yeah, we've done that before, and you
I
are
don't-
absolutely welcome to come do Q&A with them.
oh no, I really, I was a little reluctant in one hand to bring the slides along, but I also wanted to be able to get this story out about the importance of these aptitudes in data science. So let's try it again sometime where we're not constrained by slides.
Yeah, we'll just do informal. Yeah.
Anybody out there? Anybody out there want that to happen? Do I see yeses from anyone? I don't know.
Yeah, guys, if you really want
Yes,
you have like big yeses right now.
Oh boy.
All right, we'll get that in the books, guys.
now I'm committed. Uh-oh.
Yeah, we have like 12 questions here that sadly were not answered. And so please come back for the next webinar. We'll make sure that if this is what you want, you'll get it, because this is how we roll on Data Science Live. So if Kirk's open to do that, we'll be announcing very soon when's the next session for Q&A with Kirk.
Excellent. And if you can capture those questions and save them till that next time, that would be excellent.
Yeah, we can do that. We can do that.
Okay.
Part 2, coming soon.
All right, awesome.
Same hour.
And we can talk about, someone mentioned the Monty Hall problem, so we'll talk about that next time.
Oh, fun.
I saw that go by in the comments. Someone talked about the Monty Hall problem. We can have lots of fun with that one.
Someone wants you for 2 hours, so.
Okay, well, I told you I could do 3 hours, so be careful what you ask for. No, this has been great. I thank you, Kristen and Favio, for doing this for our community. It's really wonderful. So thank you and congratulations on pulling this off. This is great.
Thank you.
Well,
Have
guys,
a great night. Bye.
Have a great night, everyone.
All right, one last word.
Bye-bye.
We are here to advise the world, all of us, on how to use their data productively, and that's our mission. How to bring value out of our data. So onward and upward.
Bye.